This is the third podcast on this lecture. A little bit more practice on what we learned, so it's more practice related. We're not really learning anything new. Um, so I want you to try this problem and then go ahead and continue. So it says here find the total pressure exerted by 30 grams of carbon dioxide and 38 grams of hydrogen. So, we're gonna ignore the chemical formula in this case because we're not given one, and we're just gonna assume that everything's balanced. But essentially, what we do is because it's in a chamber, a container, and it has a specific temperature, we know we're gonna be using the PV equals nRT equation. And because we want the moles of both of these in order to find the partial pressures for both, then we could just add up the pressures and we'll get the total pressure. So let's go ahead and do carbon monoxide first. And again, we're using PV equals nRT, and we're looking for the partial pressure. So this is going to be our equation. We cannot find N without converting 38 grams of carbon monoxide into moles, and that's going to give us 1.36 moles of CO. So now we could plug it in, and we're gonna get 1.36 moles. R, we're gonna use let's use the atmosphere one, and T is gonna be 298, converting this into Kelvin, and volume is gonna be 6 liters. So when we solve this, we are going to get 5.53 atmospheres. Do the same for hydrogen. Always assume hydrogen gas, so hydrogen is H2. And so 38, so I'm going to draw a line here. 38 grams of H2, 2 grams per 1 mole. So that's going to be 19 grams, 19 moles of H2. I plug it into the PV equals nRT. Again, we're finding P. So moles is going to be 19 mole times R. And T is going to be 298. And the volume is going to be 6 liters. So when we do the math, we're going to get 19 times 0.0821 times 298 divided by 6. It's going to be 77. So the pressure is going to be 77.5, let's say, atmospheres. So those are the partial pressures. So this is the partial pressure of carbon monoxide, and this is the partial pressure of hydrogen. But it wants the total pressure. So all we have to do is add them up. So P total is equal to 5.53 plus 77.5, which is 78, 79, 90, 91, somewhere around 92 atmospheres, somewhere around there. So that's our answer. Alright, so the next problem is going to be, let's look. So the partial pressure of each gas for this one is just, what we solve for P for each one. So don't worry about that one. So you go ahead and try this one, and then once you're done, go ahead and look here to see how to solve the question. So a mixture of 6 grams of oxygen, 9 grams of methane are placed in 15 milliliter vessel at 0 Celsius. What is the partial pressure? So we're going to have to find P for each individual gas. So let's start with 6 grams of 6 grams of O2, 32 grams of O2, 1 mole. So that's going to give us the moles. And you're supposed to get 0.1875 moles. And we're gonna plug into PV equals nRT now. This is that in Kelvin. So PV equals nRT. We're gonna find the pressure. N is that. R is going to be the universal gas constant that includes atmospheres in it. We're going to find it in atmospheres. If you want to find it in kilopascals, that's also fine. The T is going to be 273, and the volume is going to be 15 liters. And when you solve this, you're going to get 0.1875 times 0.0821 times 273 divided by 15, and that is going to give us 0.28 moles. I'm sorry, not moles. Atmospheres. Atmospheres is pressure. Atmospheres. Okay, so that's the partial pressure of this is going to be the partial pressure of O2. Okay, it's that. Do the same again for methane. 9 grams of methane. 12, 13, 14, 16 grams CH4 according to the periodic table. And that's going to give us 0.56 moles. And now we plug into PV equals nRT. Same equation, the same equation right here. I'm just going to rewrite it down here. So N is going to equal 0.56. R is going to equal the universal gas constant. And T is going to equal 273. And the liters will be the same reaction vessel. When you do this, you get you're going to get a small number, 0.84 atmospheres. And then when you add them all up, that's going to give you the total pressure. So the total pressure is this 0.28 plus 0.84, and that's going to give us 1.02, I believe. If I'm wrong, I apologize. I don't know how to do simple math. 1.02 or 1.12, somewhere around there, atmospheres. So that's going to be your answer. Let me actually 0.28. Yeah, so this is 12 atmospheres. Next problem. Go ahead and try and then check your work now. Same idea. 28 grams of nitrogen gas, which is N2. 28 grams of N2 for 1 mole. Okay, this is a coincidence that they're the same. And that means you have 1 mole of N2. Use PV equals nRT. And you're solving for pressure. So this is going to be your equation. 1 mole times 0.0821 times 273 Kelvin, because that's a temperature. And volume is 15 liters. And when you solve for this, you get 1.5 atmospheres. This is the pressure of N2. Now we do the same, but this time for hydrogen. So 4 grams of hydrogen gas times 2 grams of H2 per 1 mole. Just use the molar mass. So I get 2 moles. And so I could already tell that it's going to be double this. So, because if you just plug into there, it's going to be double. It's going to be this R constant. So essentially you're just putting a 2 there. And then when you solve for that, you should get 3 atmospheres. Okay, and this is the partial pressure of H2. And when you add these two together, then you get the total pressure, which is 4.5 atmospheres. Okay, so this is your answer, this is your answer, this is your answer. Okay, so this problem right here is a little bit tricky. So what we have is a solid, a liquid, we're making a gas, and we're making a solid. It's already balanced. So we're given 0.852 liters of acetylene, which is this right here. It's collected over water at 20 degrees Celsius. We're going to assume the temperature of acetylene is also 20 because it's a mixture. You're going to find the moles of acetylene collected and the grams of calcium carbonate. So 2 different substances, meaning that we know we're going to be using the mole ratio somewhere. So what we're going to do is we're going to identify these. This is going to be V. This is going to be P. But there's a problem with P. We need the pressure of acetylene. And here we have the total pressure and the pressure of water. So because these are solids, we're going to assume that these guys do not contribute to pressure because they don't really collide with the container. The gas and the liquid do. So if we subtract the total pressure minus the pressure of water, according to Dalton's law, we could do this, then we're going to get a slightly smaller number, which is 714.5 torr. And I'm going to convert this again into atmospheres because that's what we're going to use in the PV equals nRT equation, and I get this many atmospheres. So when you solve for N, you're gonna get this. So the pressure is 0.94. The volume is that. And then the R, we're gonna use the atmosphere one. And then the T is going to be 273 plus that, which is 293. And when you solve for this, you get 0.033 mole of acetylene. And that's what we want. We want moles of acetylene, so that's it. That's moles of acetylene. But we also want to find the grams of, so this is mole of acetylene. But we also want grams of calcium carbide, so we have to use a mole ratio. 1 mole of acetylene has 1 mole of calcium carbide because it's a 1-to-1 ratio. And then we use molar mass. 1 mole of calcium carbide is going to be 40 plus 24, which is 64. 64 grams. Calcium carbide. So this times that is going to give us our answer. And 0.033 times 64. Yep, and that's what I get. I got 2.112, which is very similar to that. So that's how we do this problem. I would try doing this again so you could really understand each step of the way.